There are many basins for which no stream flow records are available. For such ungauged basins, hydrographs can be synthesized from other catchments which are metrologically homogeneous. Snyder developed a set of empirical equations for developing synthetic unit hydrographs. These are the equations developed by Snyder. We will use these equations to form a synthetic unit hydrograph of an ungauged basin. Here is the problem. A 2-hour unit hydrograph developed for catchment A revealed that its peak discharge was 45 meter cube per second. Time to peak from beginning of rainfall excess in the unit hydrograph was 8 hours. Develop a synthetic unit hydrograph for catchment B using Snyder's method. Catchments A and B are metrologically similar. So, you can use all the information given about catchment A to form a synthetic unit hydrograph for catchment B using empirical equations developed by Snyder. Now the basic information about length and area for catchment A and catchment B is given. The length, area, L is the basin length measured along the water course from the basin divide to the gauging station. LCA is the distance along the main water course from the gauging station to a point opposite to the watershed centroid. The area is also given. It is 225 kilometers square and 350 kilometers square for A and B respectively. Now, from the information given about catchment A, we will be calculating some useful parameters. So TR is given, it is 2 hours. It was already described in the problem. 2-hour unit hydrograph. Yes. So TR is 2 hours. TP is 8 hours. Time to peak. It was also given. Using the value of TP and TR, we calculated T dash P. T dash P is the modified basin lag. It is 7 hours. Now, using the value of T dash P and TR, we can calculate TP using this equation. And its value is 6.81 hours. So T dash P and TP, basin lag. TP is the basin lag in hours and T dash P is the modified basin lag. So using this value of TP and the values of basin length and LCA, we can now calculate CT. Okay, CT is the regional constant representing watershed slope and storage effects. So CT has been obtained. Now we'll calculate CP, also a regional constant. Now QP was already given in the problem. Peak discharge, it was 45 meter cube per second. Value of T dash P as calculated above was 7 hours, and area of catchment A is 225 kilometers square. So when we plug in all these values, we can calculate CP. Its value is 0.504. Now we'll begin the process for developing synthetic unit hydrograph for catchment B. Now the values of CT and CP have been obtained. Now, using the value of CT, we can calculate basin lag using this equation. Tp is equal to Ct, okay, into LLC raised to 0.3. It is 9.40 hours. Basing lag in hours is 9.4. Now using the value of Tp, we can calculate Tr, duration of effective rainfall in hours. It is 1.71. Now we have Tp 9.40, we have Tr 2 hours. Yes. So using the value of Tp and Tr, we can calculate T dash P, the modified basin lag. It is 9.48 hours. And we'll use this value of T dash P in this equation to obtain the peak discharge. 2.78 into Cp, Cp was already obtained, 0.504, using this equation for catchment A. Okay, Cp into A, area of catchment B, 350 kilometer square, and T dash P 9.48 hours. So plugging in all these values to obtain QP. So the value of QP is 51.7, rounding it up to 52 meter cube per second. So the value of peak discharge for catchment B using Snyder's equations was found to be 52 meter cube per second. Now W50. W50 is the width of unit hydrograph in hours at 50% peak discharge. Here it is. This is W50 and this is W75. QP is already obtained. TP is also obtained. We need to find W75, W50 and base time for catchment B. So W50 can be easily obtained using this equation 5.87 by Q raised to 1.08. Q is QP by A, and we have the value of QP, and the area is also available for catchment B. So W50 is 46 hours, and we'll use this equation to calculate W75, W50 by 1.75, and basin lag can be obtained using this formula. uh, 72 plus 3 T dash P, and the base time obtained using this equation is 100 hours. Now for smaller catchments, this equation is more reliable. TB is equal to 52 hours. This equation was not developed by Snyder. It uh, was developed by Taylor and Schwartz. Okay, T dash P was already calculated. We have TR, and by using these values we obtain the base time. So TB is obtained. W50 is 46 hours. W75 is 26 hours, and QP and QP is 51.7, or you can say 52 meter cube per second. And then we can uh, draw a smooth curve to obtain the unit hydrograph, synthetic unit hydrograph for catchment B. W50 uh, has been obtained, W75 has also been calculated, peak discharge is also available now.